So today we are going to discuss this problem on Codeforce. I can't help but want to explain this problem because it is a very interesting problem. I haven't done this for a long time, but today I try to solve this problem and take me several hours. So just want to record this. Okay, so it's a K-good problem. So basically, it will give you a number n, and you need to decide if this number is K-good number. So what is K-good? So basically, you need to break this n into K numbers. And these K numbers have to meet one condition, which is the remainder of each of these numbers should be distinct. The remainder of when you divide each of the number with K, the remainder must be distinct. That basically means that these numbers, when you divide these numbers with K, each of the remainder must appear exactly once. For example, the first number's remainder is 1, second is 2, third is 3, fourth is 0, right? Each of them should appear exactly once. And how are we going to determine if a n number is K-good? So the stupid solution is just iterate each of the case. All right, you try 1, 2, 3. Actually, the K must greater or equal than 2. So we will start at 2 and try each of the possibilities. So that is not good enough because n is in the range of very big number, right? So how can we do this? So basically, each of the remainder will appear exactly once. That's a lot of information. So basically, we can change the form of n since each of the remainder will appear exactly once. So we will transform it to something like this, right? So these are all the remainders, and this is the part where you divide K, right? This is a integer number, which is T should be equal or greater than 1, right? So let's take a real example here. So basically, if the n is 6, then you should find these consecutive numbers like this, and plus 3. K here is 3, right? Plus K multiplied by 1, right? So how are we going to make use of this formula? So basically this formula can be transformed into this guy. Right. And this guy can be transformed into we multiply both sides by 2. So it is like this. And we extract the k out. This is what we get. Right. This is a very interesting formula. So basically, what can we get from this formula? We can get a lot of information. For one, this side is an even number because n is an integer. So 2 multiplied by n is an even number. That means this side is also an even number. And let's take a look on k here. This guy, one of them should be even and one of them should be odd. Why? Because sorry, I miss a 2 here. So basically when you multiply each side by 2, you should have a 2 here, right? So here, this guy is a even number. And this guy and this guy should have the same, what you call the attribute of even or odd. Never mind. So basically, this even number should not matter for this guy and this guy's even or odd attributes, right? And this guy is minused by 1, so this guy's attribute should be different than this guy's, right? So one of them is odd and one of them is even. So when we have a n and we got the 2n here, for example, if the n is 6, we got a very limited number of combinations here because this guy and this guy are integers, right? So basically, if we can get a odd number and a if we get a even factor from this guy and a odd factor from this guy, then we can be sure that we can solve this function here, right? Because let's say because t is bigger than 1, then this side should always be bigger than this side. And if we can find a even factor of 2n and a odd factor from 2n, then we can be sure that we can solve this formula. We can just basically assign the smaller one to k. This is even and this is odd factor, right? And the other one is the maximal one, right? Then with these two formulas, we can get the answer for k and t, right? And this will be always solvable because the t is k and t are integers. So these two formulas can always solvable. So the problem translated into a really easy question. So can we write n to multiply n? Can we write this number into something like even multiplied by odd, right? And that can be done very easily. So basically, we can just divide n by 2 again and again, and get a even number, and eventually what remains is a odd number, and we can compare that odd number with 1 to see if it is possible to get the odd number that is not 1. So I guess that's it. I need to get out to eat. See you guys.